Okay, so for this problem, we want to find the term that's independent of x. That means it's got no x. Or it's going to have a power of x to the 0, which is going to make it a constant. All right, so to find that, what we've got to do is we've got to find the term that has our x's that get a 0. You'll notice, though, we've got two of them, so we've got to kind of keep that in mind. Now, I want to do this two different ways. One is by raising it and making the exponent negative, and then the other one is leaving it the way it is, like the way it is in the video that you watched. It doesn't make a difference which way you do it. I prefer this first way, but I'll show you both ways, and you can do it however you want. So here we got it set up. We know it's going to be a 9 on the top. We can guess on check, and we can pick some numbers. We know that together they have to add the 9. So let's see, if we try, let's see, a 2 here, that means that would be a 7. Well, that's going to be negative 8 and 7. That's no good. So then if we try 4, well, that's going to be negative 8 and 5. That's going to give me a 3. That's no good. So then if I try a 3, well, that's a negative 6 plus 6. That's going to give me a 0. Well, now I can put the 3 down here at the bottom of my combination. And if you look at the other side, well, now you have to visualize this as being a fraction. This x is going to be on the top of the fraction, and the x squared is going to be on the bottom. So what I need is, again, a number that's going to divide and make them cancel out. In this case, it's still going to be the 3 and the 6, because what's going to happen is you'll see I'll have a 6 on the top and then a 6 on the bottom. So anyway, let's go back over here and figure this out. If we do 9 combination 3, 9 choose 3, we're going to get 84. And this is obviously going to be x to the 6th power. Then it's going to be negative 1, because 1 to the 3rd is negative 1. And then negative 2 to the 3rd is negative 6. I can multiply negative 1 times 84. And then you see that the x and the 6 and the negative 6 will cancel out to 0, giving me a negative 84. Well, this works the same way. I'm going to have my fraction here, x to the 6th. And then I've got negative 1 over x to the 6th. And so then when I multiply those together, and most put parentheses around them, so when we multiply these together, it's going to be 84 x to the 6th, and then times negative 1, all over x to the 6th. Well, you can see the x to the 6th cancel out, giving me negative 84. So you get the same answer in either case. It doesn't make a difference which way you do it. Now, that algebraic method that you saw in the video, if you put an r in the one place and a 9 minus r in the other, well, then what we can do is we can use algebra, but we just got to take a look at just the x's. So if you kind of pull this out, this is going to be x to the 9 minus r, and this is going to be negative x and then negative 2 times r. That's going to be negative x to the negative 2r. Well, now remember, when I multiply two guys with monomials with powers, I add them together. So it's going to be 9 minus r plus negative 2r, and I want those exponents to equal 0. Well, so then I get this, and then when I move the negative 3 over to the other side, I'm going to get r is equal to 3. And if you do it with the other problem, this algebraic method still works. You put the r here, and then you put the 9 minus r here. And the only difference is that, like I said, it's going to be a fraction. You're going to have x to the 9 minus r over x to the 2r. And then when you're dividing, you subtract them. So it'll be 9 minus r minus 2r equals 0. And of course, you're going to get the same answer, r is equal to 3. Okay, so I hope that helped, and thanks for watching.